Well, welcome back. You're ready to check some aldehyde and ketone nomenclature, and I'm just going to walk through these examples, see if we come up with common answers. So the first I notice in structure A is an aldehyde, and I know aldehyde, the carbonyl carbon gets priority 1. So there's carbon 1, 2, 3, 4 carbons in that parent chain. So I know that I'll have a butanal as the parent. Looks like at carbon 2 we have a methyl substituent group, and at carbon 3 is another methyl. So you properly named this 2,3-dimethyl, and then you checked with butanal, Al ending for the aldehyde. You know with letter B, the priority has to be given carbon 1 for the aldehyde functional group, and there it is. This is the aldehyde, CHO. So there's carbon 1, 2. I'll head out this direction to find the longest parent chain as a 5-membered ring or 5-membered chain. And so we'll hear that as pentanal. At carbon 2, there is an ethyl group of a 5-carbon parent, pentanal. 2-ethyl pentanal. Doing all right so far, I bet. Well, let's see what we have here. Right here is carbon 1. I can see that that's the aldehyde. Here's carbon 2, 3, 4, 5. And off of carbon 5 is a pair of methyls. So remember to just kind of think this out. Here is your carbon 1. And so I'll just make that a hydrogen, carbon 1. And then we're attached to 5 carbons, 2, 3, 4, 5. And then carbon 5 is attached to 2 methyl groups. So just think of that as 2 groups of methyl coming off of carbon 5. So the parent chain now is 6 carbons long. At carbon 5, we do have a 1-methyl substituent group. The parent is 6 carbons long, ending with an Al, 5-methyl hexanal. Here's our functional group. Carbon 1 is the aldehyde. Carbon 2, we better start sketching this, right? Here's B. Let me try to get my attachments. Here's carbon, that's the aldehyde. I called it 1. Next door, I called that carbon 2. And then notice here, this, I got to figure out what all this is happening, right? I have carbon attached to 2 methyl groups attached to another carbon. So thinking that out, this would then be carbon 3 attached to 2 methyl groups, which is then attached to another carbon attached to 3 methyl groups. So let's be sure you see this. Attachments are so important. Let me highlight the carbon so you can kind of get a very clear visual here. This carbon that I just highlighted in yellow is attached to 3 methyl groups, and it is. So that carbon I colored in yellow meets the criteria of being attached to 3 methyls. How about I color this one in green, and that's this guy. That green carbon is attached to 2 methyl groups, and it is up and down, and then it leads to a CH2, CHO, the aldehyde. So that's our attachment for letter B. Make sure you take the time to make sure you've got all of that written correctly, and just kind of make sure you see where all of those methyl groups are hanging on. This has 2 hydrogens, so we've completed the octet for all of those carbons. We numbered this. Let me just make that purple. 1, 2, 1, 2, 3, 4, 5 carbons in the longest carbon chain. Let's see. At carbon 3, there's 2 methyl groups. At carbon 4, there's 4 methyl groups. I'm sorry, there's 2 more methyl groups. The substituent branches, let me highlight in blue. There's 1, 2, 3, 4 methyl groups in a 5-carbon parent. So 3, 3, 4, 4, tetramethyl. And then a 5-carbon is pent and al. That was a good one. How'd you do with letter B? 3, 3, 4, 4. All 4 of those methyl groups have been located, right? There's 4 of those attached, 2 on carbon 3 and 2 on carbon 4. The prefix for 4 methyls is tetra. That was a doozy. Let's keep trying. These are fun. Let's just keep trying and see what we find. All right, here's letter C. I know that this is carbon 1. The aldehyde gets priority. Carbon 2, 3, 4, 5, 6, and I can go up and find more, 7, 8. 8 carbons. Let's see, we've got some branching. We have a branch at carbon 5 and a branch at carbon 6. Both of those are methyls. And we have an 8 carbon chain, and it will end in Al. 5, 6 dimethyl octanol. Doing good work. Now we'll go the other way. Let's draw the structures for each of the following compounds. So, all right, I can see it's an aldehyde. It ends in Al. I know that the parent chain contains 3 carbons, propanol. So why don't I just get that part started? I know a 3 carbon chain, and I know that the aldehyde group will be at carbon 1, and I'll just put it at the end there for carbon 1. And then at carbon 2 is a chlorine. So I can just take a chlorine and make an alkyl chlorine. So we have 2-chloropropanol. And of course, we would know that there are hydrogens there to complete the octets. So you'd have CH3, and then a CHCl, and then a CHO would be its structural, condensed formula like that. You could look at this as 1, 2, 3. Off of carbon 2 is a chlorine, and off of carbon 1, you have a double bond to O. All right, so those are some choices. That's our structural. Give the structure. You've got C, C, C. Carbon number 2 has a chlorine. Carbon 1 is the aldehyde functional group. Let's look at letter B. Heptanone. 1, 2, 3, 4, 5, 6, 7. 7 carbons. And I just tend to make the functional group of the aldehyde at the end and call it carbon 1. And so if I just number from right to left, there's my 7 carbon chain. At carbon 3 is an ethyl. At carbon 4 is another ethyl. And at carbon 5 is a third ethyl. 1, 2, 3, 4, 5, 6, 7 carbons, where we have a double bond O at the end. At carbon 1, 2, 3, there's an ethyl. Carbon 4, there's an ethyl. Carbon 5, there's an ethyl. Something like that. All right, let's keep going. Nonanol, 9 carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9. And there's my terminal carbonyl carbon for the aldehyde. And just to remind you that we number with that always as carbon number 1. There's my 9 carbon chain with the aldehyde at position 1. At carbon 3 is an ethyl group. And at carbon 6 is an ethyl group. Thinking that through in structure, 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons, where the last carbon has a functional group of a C double bond O. And then at carbon 3, 1, 2, 3, there's an ethyl. And at carbon 6, 1, 2, 3, 4, 5, 6, here's another ethyl. All righty, let's try letter D. Ethyl, oh, there's an ortho position of benzaldehyde. Now, do you remember your benzaldehyde? You have your benzene ring. And then the aldehyde functional group. And in the ortho position, ortho meaning 1, 2, so there's position 1. At position 2, you would have an ethyl group. That would be ortho ethyl benzaldehyde. These are now ketone practices. Ketones end with O-N-E. I know that the ketone gets the priority when numbering. We find the longest carbon chain. Let's see, at position 3, we have a substituent branch of a methyl. And at carbon 2 of a 5-carbon chain, there is a carbonyl to make a ketone. 3-methyl-2-pentanone. Here's a ketone in a cyclic structure. It automatically gets carbon number 1, 2, 3, 4, 5, 6. Numbering in this direction gets the first substituent at the lowest number. And I'll alphabetize. 3-ethyl, 4-methyl, cyclohexane. Lots of things to say, huh? 3-ethyl, 4-methyl, cyclohexane. Oh, beautiful work. Couple more yet. Keep checking with me. Let's see. Carbon 1, 2, 3. That's the lowest position. 4, 5, 6, 7. I count 7 carbons in the longest chain. At carbon 4, I see a substituent branch of a methyl group. At carbon 3, of a 7-carbon chain, we have a carbonyl ketone. 4-methyl, 3-heptanone. Here's a cyclic structure. So the ketone there, the functional group is a ketone, automatically carbon 1. And we're going to number counterclockwise to give the methyl group the lowest number. So we would say this is 2-methyl, cyclo. It's a 5-membered ring, so pentanone. Beautiful. Let's see the last one here. 1, 2, 3, 4, 5, 6, 7. That parent is a heptanone, and we have 2,2 dimethyl. And then at carbon 3 is the, oops, not hept for 7, heptanone. 2,2 dimethyl, 3-heptanone. Oh my goodness, we're doing better. Each time we practice, we become more proficient and speedier. Give the structure for each of these. Let's continue checking. I know that you've worked ahead of me, so that's why I'm going fast. Letter A says butyl ethyl ketone. That's a common name. So we have a ketone functional group. On one side, we have a butyl, 1, 2, 3, 4. And on the other side, we have an ethyl. So that's just alphabetized butyl ethyl ketone. An IUPAC name would be 3-heptanone. Same structure, just common. You have the butyl, 4 carbons. You have the ethyl, which is 2 carbons. And then you say the term ketone for that carbonyl. Alrighty. All right, so that's A. How about B? Let's see. At carbon 3 of a 5-carbon chain. So 1, 2, 3, 4, 5. At carbon 3 is the ketone. And at carbon 2 is a methyl group. Alrighty, so that's what this looks like. 1, 2, 3, 4, 5. At carbon 2 is the ketone. At carbon 3 is the ketone. And at carbon 2 would be a methyl group. That's kind of the structural look for letter B. How about letter C? Para-ethyl acetophenone. All right, so remember this. In terms of phenone, we had to go back and look at that structure for phenone. And that was the aromatic compound where you had a benzene ring. Oops, that's not a very pretty benzene ring. 1, 2, 3, 4, 5, 6. Alternating single, double. And then we had the carbonyl leading out. And then see how that is a CH3 for that parent name, acetophenone. Now what else is on it? In a para position, so that's 1, 4, para, there's an ethyl group. So 1, 2, 3, 4, there is an ethyl group. So that would be 2 carbons coming off of that chain. Perfect. Ethyl group at 4, and the acetophenone functional group gets priority 1. How about letter D, 2-propyl cyclobutane. All right, let's take that one apart. Let's draw it right here, letter D. I can hear a cyclobutane. 1, 2, 3, 4. There's a 4-membered ring. There's the cyclobutane. And wherever I put the carbonyl group coming out, that will be carbon 1 automatically. And then I'll just go clockwise to make this carbon 2. And there it says there's a propyl group. So 1, 2, 3. And make that a little neater. Carbon 1, 2, 3. It kind of gives it a better zigzag there. So there we have 2-propyl cyclobutane. Oh boy, let's keep practicing. Draw the structure of a compound that fits each description. We have an aldehyde with the molecular formula C8H16O. It has 6 carbons in the longest carbon chain. All right, let's play with this. 1, 2, 3, 4, 5, 6 carbons. It says it's an aldehyde, so I know that right there is my functional group, the aldehyde. It means we have 2 more carbons to place. So we can really do it anyway. We can put one here, and we can put one there. There's lots of choices there, isn't there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and of course there's your 16th hydrogen. So that works. We had a 3, 4 dimethyl hexane al is one example. There's other correct answers, but you get the idea. You could have put your methyl groups really on carbon 2, 3, 2, 4, 2, 5, and any other possible combination, as long as you don't extend the 6-member chain. Let's look at B, a ketone with the molecular formula C6H12O. And this time, we can only have 5 carbons in the longest chain. All right, so here's our idea. 1, 2, 3, 4, 5. And it has to be a ketone, so I can put my ketone either on carbon 2 or on carbon 3. Those are equally valid choices. And I can put a methyl group on, really on carbon 3 or 4. Doesn't matter. So that would work. I have 3 methyl, 2 pentanone. But no, that's not the only correct answer. I mean, let me just give you another idea. What if we did a 5-carbon chain and you put the ketone at carbon 3? You could certainly put a methyl group next door. And here you would have 2-methyl, 3 hexanone. That's also a perfectly valid answer. Not hex, Linda, hept. I'm so sorry. That's a 5-carbon chain. Well, let's see letter C, a ketone with the formula C5H8O, and it has a ring. All right, so let's draw a house. 1, 2, 3, 4, 5-membered ring. And to make a ketone, this is just called cyclopentanone. Here we have 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. All the octets have been satisfied. And letter D, an aldehyde of a molecular formula C6H10O that has the aldehyde group bonded to a ring. So I'm thinking there we need a 5-membered ring because the 6th carbon has to come out as the aldehyde. So that's 6 carbons. 1, 2, 3, 4, 5, and the 6th carbon would be that in the aldehyde there. And then of course you would have enough hydrogens to satisfy the octet of each. 1, 2, 3, 4, 5, 6, 7, 8. This guy has just 1, 9, and there's the 10th one on the aldehyde. So that would be a 5-membered ring with the aldehyde coming out as a branch. Did you get that one? All right, you just keep practicing. Oh my gosh, one more to check. We're in the home stretch, my friends. Draw the structure of a constitutional isomer of 2-heptanone. So notice what we have. 1, 2, 3, 4, 5, 6, 7. At carbon 2 is your ketone. 2-heptanone. Now we want to draw a constitutional isomer, but it has an aldehyde functional group instead of a ketone. Well, how about a 7-membered chain? 1, 2, 3, 4, 5, 6, 7. But now all of a sudden we make this guy the aldehyde. This would become heptanal. How about if it contains a ketone? Well, that's just as easy as moving where the ketone is. And so instead of at carbon 2, we could move it to carbon 3. We could even move it to carbon 4 and still have a constitutional isomer. So this would be 2-heptanone. How about contains an alcohol hydroxyl functional group? Now that's limitless. 1, 2, 3, 4, 5, 6, 7 carbons in a chain, and you can put that alcohol group at absolutely any one of those 7 carbons. You could have put it at carbon 1, and you could have made 1-heptanol. You could have placed it at carbon 2 and made 2-heptanol. You could have put it at carbon 3 and made 3-heptanol. And there's even a unique position at carbon 4, and that's right where you start to repeat. So carbon 4 is also unique, but there is no carbon 5 because that's the same as carbon 3. So that's a lot of choices there. All right, oh my gosh, give yourself a big old star. It just feels good. You've made it through the nomenclature practice. You've now kind of made it through to the top of page 6 in your notes. I'll pause the video. You're going to come back and do a little more interactions, intermolecular attractions with aldehydes, ketones, look at some physical properties, and we'll start to look at some reactions as well. Good work for today.